This conference will now be recorded.
Very good afternoon to all. So let me start the session. I don't want to wait further. So those who are joining late can join, no issues. So am I audible, students? Am I audible?
Yes, sir.
Okay,
Yes,
okay.
sir.
Okay, thank you, thank you. In between, if you face any audio issues, kindly let me know so that I can rectify. Right. Okay, ma. Thank you, thank you. So I welcome you all for the day 2 session of digital communication course, right? So in your very first unit, is slide visible? Is slide visible for you all?
Yes, sir.
Okay. So your very first unit is basics of information theory coding. In this unit, okay, Jai Sharma. So in this module, we are going to see what is Shannon's channel capacity theorem, Huffman coding, Shannon-Fano coding, entropy, mutual information, and discrete memoryless channels. So these are all the major topics we are going to cover in this very first module, right? So before going into this module introduction, let me discuss what we have discussed in last class. So I have given you clue in this slide itself. We have discussed about communication theory, right? Can you brief what we have seen in last class, that is Monday's class? You can unmute and answer, or else you can put a reply in chat box. Anything is okay for me. Yes, can you reply? What we have discussed in last session? Students, I am asking you only. Why you people are so silent? Very good. Modulation, demodulation, types of signals, and the basic things of very good, Disha and Jai Sharma. So we have covered basics of communication, what is actually communication, and what are all the process involved in communication. Everything we have discussed. I have given you one small scenario. Can anyone tell me what was that scenario? I have given you one small scenario about the communication. Can you tell me what is that? Yes, students? You people are very bored. Warfield. Okay. What is Warfield? I can't get you, Nirmal. No idea? Shall I tell? Shall I tell? Yes. Okay, Naveen. So I have given you the simple analogy of classroom. Offline class go, online class go. What is the difference? I have explained you, right? Very good, Disha. So in online class, we people are connected virtually, and what are all the things that should happen around us to get connected with each other? Everything we have discussed. Whereas in our offline class, one room is enough, and entire people can sit in that, and one can speak, others can listen, or else others can speak, and vice versa process can take place. Now can you able to recollect this concept? Yes or no, students? Can you able to recollect? Yes, okay. So others do reply. I'm expecting all of you to reply me, right? Okay. Now, so let me quickly rush up what we have discussed in last class. So you people have said answer for communication. That is nothing but sharing of information or transferring of message from one place to another place is called as a communication, right? So this is what we have seen in last session. So what are all the things we need for communication is one is transmitter, another one is receiver, right? So in between we need channel. So to establish a connection from transmitter to receiver. Varun Pandian have replied as simplex, half duplex, and full duplex. Very good. That is types of transmission modes. Okay. So for this feedback only, I have given a small example of normal messaging and WhatsApp messaging. Yes. Normal messenger to WhatsApp messenger. I have given you one small example which you will prefer, right? Do you remember that scenario? Yes, do you remember that or not? Do you remember I have given one small example of normal messaging and WhatsApp messenger? Why we are going with WhatsApp? Yes or no? Yes, okay. So because of that, receiver sender can know the status of receiver whether the message is delivered to that person or not, right? So that is what you are very good. That is called as an acknowledgement. So that the connection will be in a closed loop. So this is what your major communication involved in the major steps involved in your communication process, right? Now one question to you: where comes the picture of wired communication and wireless communication? With this, we will start with our today's class. Where comes the picture of wireless communication and wired communication? Telephone used wired communication. Excellent answer. I'm asking which, so in which component this wired and wireless communication plays a major role? Which component determines its wired communication or wireless communication? Very good. So channel determines it is the wired communication or it is wireless communication, right? So why? Because your channel is determining, because sender and receiver are connected by channel only. Connecting the transmitter and receiver is connected by channel. So if that channel is a physical medium, that is wire in the sense, that is called as a wired communication, or if not, it is called as a wireless communication, right? Now, can you tell me the example for wired communication and wireless communication? Can you tell me one example for this wired communication and wireless communication, students? Already Darun have answered for this wired communication. Telephone, that is landline phone, uses wired communication, right? Next, can you tell me one example for wireless communication? Very good. Radar, a smartphone, everything. Very good, very good. Whatever we are having, laptop, everything we will be having wireless communication, right? Now, here comes into the picture of analog communication and digital communication. Now, before going into this analog communication and digital communication, my question is, why it is called as analog communication and why the next one is called as digital communication? Think for a while and tell me why it is like this, named so. Which, based on which parameter this communication is categorized into analog communication or digital communication? You people have rightly pointed out the channel determines whether it is wired communication or wireless communication, right? Now my question is, which parameter will describe whether the type of communication is analog or digital? Based, excellent Naveen, very good Nirmal. So based on the type of message signal what we are going to transmit, right? So if you want to transmit the message entirely in analog form, I should not disturb that, or I should not do any sort of conversion, then that is called as an, that should be carried out by your analog communication. Whereas my signal I can alter and I can transfer, then that is called as a digital communication. Hope you are clear with this two concept. So this analog communication and digital communication comes into picture, which is based on your signal what we are going to transmit. Yes or no, students? Yes. Yes, can you reply? Okay. So with this, let me go with the, wait a minute, my slide is getting changed. So now question to you, is the slide visible for you all? The slide visible or not?
Yes, sir.
Okay, right. You people have rightly said that communication is categorized into analog and digital. It is entirely based on the type of message signal we are going to transmit. Now, one normal question to you, since you people have completed signals and systems and digital signal processing, everything, one small question to you. Can you give the examples of analog signals and digital signals? Think for a while, take your own time and tell me the answer. Nirmal have rightly answered. So sine wave, voice signal, and or these signals are called as an analog signal, right? Then digital signal is, what is digital signal then? Rectangular wave signal. Okay. Any other answers? Computer signals. It is called as digital signal. I agree. Radio signal. Okay. Then. So you're naming some signals, rectangular signal or computer signal or normal square wave signal, radio signal, everything will be taken by, is categorized under your digital signal, right? Now question to you, which of the above signal is efficient? Whether you will say analog or digital, or both are efficient, or it depends upon the application. What is your answer? I have given you clue. It can be analog signal, or it can be, or your answer can be analog signal or digital signal or both, or any of the signal depending upon the application. Dharn have said as depend upon application, and Madhumita have said as digital. Okay. Any other answer, students? Risha also said as digital. Okay. Very good. So, right. Let me keep hold on this and I'll come to the signals type. So say for example, if you analog is better, right? Very good, Naveen, and justify your answers. So you are saying that let us consider the analog signal, right? Let me assume that sine wave which is having, let me draw in this. Okay, let me take one analog signal, that is, let me take it as sine wave. Okay, so this sine wave, if it is having amplitude of 10 volt, bear with my diagram. So if this sine wave is having amplitude of 10 volt, what should be this amplitude level, and what should be this amplitude level? I said total as 10 volt, right? So what is the positive value and what is the negative value? Students, can you get? Very good. So it is plus 5. So, and this is here minus 5 volt. Are you clear with this? Do you agree that this is analog signal? Yes. Do you agree this it is an analog signal? Yes or no? Yes. Now, can you tell me digital signal? Let us take a normal square wave. So let us consider this as a digital wave. What will be the amplitude level? What will be the amplitude level for this digital signal? What is this di stands for? Di, digital level, di stands for what is the meaning? Very good, Kanmani. It's 1 and 0, 0 to 1. Two levels you'll be having. So it is 0, it is minus 1 plus 1, right? Okay. Can you understand this? Yes, students? Are you clear with this? Okay. Now tell me, if I want to transmit this analog signal and this digital signal, which one you will prefer? You leave off this what type of signal, everything you leave off. Which one will be easier for transmission? Either the sine wave which is having 10 volt amplitude or digital signal which is having 2 volt amplitude. Which one will be better? Digital. Very good, very good. May I know why you will be preferring digital signal? May I know why you will be preferring this digital signal, students? Only two numbers are possible, right? So after this low power requirement, very good, very good, very good. Power consumption will be less. Excellent, excellent. So right. So the thing is, so further processing of this signal during transmission as well as during reception will be better for digital signal rather than your analog signal, because the analog signal will be having a high amplitude level, whereas digital signal will be having low amplitude level. As a result of that, all your resources will be getting utilized properly. Yes. Now can you answer for third question? Which of the above signal is efficient for data transmission process? Which of the above signal is efficient for data transmission process? Yes, digital signal. Very good. So I hope you have got my point. So analog na eppadi irukanum solliruken, digital na I have told you how the signal should be and which of the above signal is better for your transmission purpose, right? Shall I proceed, students? Shall I proceed? Okay, right. Now let me go with your description of analog signal and digital signal and discrete signal. So I hope you remember in my previous lecture I have told you to find out what is analog signal, what is discrete signal and what is digital signal. Have you gone through that or not? Have you gone through that? Yes, say something. Have you gone through that analog, discrete, digital? Have you heard of these terminologies? Have you heard of these terminologies? Analog, discrete. Analog is also called continuous, discrete, and digital signal. Yes, okay. Have you gone through that or not? If no, no problem. Let me explain you what is that analog, discrete, and digital signal. So you know you are very aware of analog signal, which is nothing but it is continuous signal and it changes with respect to time. Okay, you can able to see that in the last column in this picture, leftmost side denotes your analog signal, which is having a continuous amplitude level and it varies with respect to time. I'll come to the discrete signal as a last point. Now digital signal is discrete in both amplitude as well as time, meaning that analog signal amplitude levels are converted into zeros and ones. Now, what is that discrete signal in the sense? It will be having continuous amplitude, but it is discretized with respect to time. So let me draw the diagram for this. Let me draw the diagram for this analog signal, how it is discretized. So if you are having a waveform like this means, I hope you remember this. You have studied in your signals, everything. Yes or no? Yes, students. Can you able to recollect this picture? So bear with my diagram. So can you able to see this diagram what I have drawn in the screen? Yes, can you able to see what I have drawn in the diagram? Yes. So how that signal is? So it is discretized with respect to time alone, and I have not disturbed any amplitude level. That is what the signal is called as a discrete signal. So first thing is analog, and second one is discrete, and last one is your digital signal. Are you clear with this concept, students? Yes, are you all clear with this? So yes, okay. So with this, let me go with next kind of thing. How this analog signal and discrete signal. So why I'm stressing much on this topic is, if you understand this analog, digital, and discrete signal in clear manner, then only you can able to go with what is digital communication and what are all the process involved in digital communication, right? Now, let me show you the general block diagram of communication system. You are aware that whatever signal, what are all the components involved in normal communication is transmitter, channel, and receiver, right? So this is what we know, right? So that is what your general communication system is. This transmitter will be transmitting a signal via channel, and receiver will be receiving that signal. Now, what should be the transmitter? Next question to you. What should be the transmitter? In general communication terminology, we can call that as a transmitter. What should be that transmitter? Can you tell me any one example for transmitter? Yes, can you tell me the example for one transmitter? It can be anything. Whatever comes to your mind, you can answer. Antenna, very good. Mobile phone, excellent. TV remote, everything. That is what I'm called. So you are saying different answers, right? So that is what generally called as information source, which is shown at leftmost end. Can you able to see that? Yes, students, leftmost side of your block diagram, the very first block is nothing but the information source. Whether you are aware of, can you able to see that or not? Yes, okay. That is what your information source. It can be any type of transmitter, as you people have said. It can be mobile, or it can be one antenna for transmitting a signal, or TV remote to operate and everything, right? So this is what your information source. It will be transmitting some message signal. Someone has said as mobile phone. Mobile phone in the sense, mobile phone la நம்ம என்னென்ன மாதிரி signal transmit பண்ணலாம்? Can you tell me that? Through mobile phones, what are all the signals we can able to transmit? Students, through mobile phone, what are all the things we can do? Message signal, very good. Normal text message we can transmit. Then IR signal, infrared signal. Okay, then see, I don't know why you people are so silent when I ask about mobile phone. What are all the things you are doing with your mobile phone? First thing, you can put a text message, right? Then can't you able to transmit data sharing? Very good. Can't you able to make call to your friend through a mobile phone? Very good, Naveen. Voice message also we can send. That is, we can call it as an audio signal. Then that's it. Only these things: data, voice, data sharing, IR signal, everything. File is excellent. So that file is also again comes into picture of your document, right? Or text. Then can't you able to transmit image? Very good, Nirmal. What I have asked, you have answered. You can able to transmit one image, right? Video, excellent. So these are all the various things we can able to do with the information source, and these signal are called as a message signal. Can you understand what is your message signal? Can you understand what is the message signal? So I have took a normal mobile, and with that mobile phone, I have described you what should be the message signal, right? So now, if for example, you are sending one voice message to your friend, what you will be doing? You will be turning on your internet and you will be speaking something in your WhatsApp and you will be transmitting. Now, which is your message signal? Now, which thing is message signal in this scenario? What I have told? நான் சொன்னதுல இப்ப எதுப்பா message signal? You are going to transmit one voice. Very good, Naveen. So audio signal is nothing but a message signal, right? So this is what your transmitter. Now some process are happening inside your mobile phone and it will be transmitted. So without internet connection, can you able to transmit your audio signal? Without internet connectivity, can you able to transmit one audio signal to your friend through WhatsApp? No, right? So once, very good. Once you turn on your internet, what is happening? One channel is established. Okay. So you will be getting one network. So one connectivity is established from your mobile phone to base station. That is in electronics communication terminology, we are calling it as a base station. So through the channel only, it will be going to your receiver. I hope you understand. Now the received signal, you have to tell me what is that received signal, and receiver is nothing but your destination to whom you are going to send that message. That is what your receiver is, right? So message signal received will be given back to your user of information. So it is given to desired user who is going to extract the information. Are you clear with this concept, students? Are you clear with this? Yes, okay, right. Thank you. Now, can you differentiate transmitted signal from received signal? I have mentioned both the terms in past tense, transmitted, received. What will be the difference between your transmitted signal and received signal? What is transmitted signal and what is received signal now? Modulated. I am not touching upon communication blocks and everything, right? Generally, if I have message அனுப்பியிருக்கேன் ஒரு audio signal அனுப்பியிருக்கேன் received signalல என்ன இருக்கும்? So you go with that same scenario. WhatsApp messaging laye transmitted signal is nothing but your audio signal, and what should be the received signal? Audio signal, right? So say for example, if I'm speaking something, okay, in while doing taking, you consider this online class scenario itself, I'm speaking something. If one external disturbance is occurring at my end, say for example, somebody is disturbing at me, transmitted signal contain more noise than received signal. Right, Jay Sharma? Now the thing is, I'm speaking something and I'm getting one disturbance at my end. Say for example, one TV la volume adhigama vechu they are seeing on movie like that. What are all things that will be transmitted now? My voice along with my disturbance. That is what we are calling it as a noise. So noise can randomly add at your channel. But what is the actual thing I need at receiver end? Receiver is not aware of that noise, what is happening, right? So at receiver side, what alone should be received for that receiver? Receiver க்கு எது மட்டும் இருந்தா போதும்பா? Receiver should contain one, take only that voice. What, very good. Voice what is being transmitted. Now this noise is nothing but unwanted information, and what we want to do, we want to minimize this noise. I'm saying the word minimization, not completely elimination. There is lot of difference between minimization and elimination. Noise is unpredictable and it cannot be eliminated completely from our data transmission. Okay, so for this purpose only noise plays a major role that can be added at your channel, or it can be at your transmitter end, or that can be at your after your channel also it may get added. Right, now if I denote a transmitted signal as x of t, that is continuous signal ne vechirkalam. Since I am going with analog, I am saying everything in terms of a continuous signal y of t and noise as n of t. Right, now can you relate y of t with n of x of t? How this y of t and x of t are related? So I said your transmitted signal is x of t, received signal is y of t, noise is n of t. How this received signal and transmitted signal are related with each other? Can you say the relation between y of t and x of t? Received signal is equal to, I'm saying that my noise is getting added at channel. Okay, so what will be our equation? Very good. So minus or plus, Jay Sharma? So it is y of t, let me write it here, y of t is equal to x of t plus noise, that is n of t, right? So this is what the relation between your transmitted signal and received signal. Received signal is nothing but y of t, which is combination of the transmitted signal along with your noise. Are you clear with this concept, students? Yes, are you clear with this block? Yes, okay. Now say for example how this noise should be. Noise is unavoidable. How this noise should be during your transmission process, whether it should be high or low. High ah irundha ennavagum, low ah irundha ennavagum? How the noise signal should be, whether it should be high or it should be low. Students, are you all with me? Very good. Noise should be always be low. So now recent research is going on in this noise process alone. So how to minimize noise during your data transmission, right? Now one small question to you. Noise elimination can be easy at which communication? Analog communication or digital communication? உங்களுக்கு analog signal na என்னன்னு சொல்லியாச்சு, digital signal na I have taught you what is the digital, and discrete also I have explained you. Now you have to tell me which one will be easy, which communication is easier for eliminating your noise and why. Think for a while and tell me. So elimination of noise is easier in analog signal or in digital signal? Yes, students? Digital signal. Very good. Darun have rightly pointed out, because you know that digital signal will be having two amplitude level, 0 and 1, or -1 and +1. Okay, I don't want to touch upon that. Whereas analog abdina, it will be having n number of amplitude levels, right? Say for example, +5 to -5 abdina, amplitude is 10 volt எடுத்துக்கலாம், right? So noise is unpredictable and it cannot be measured or anything. Say for example, which one will be, so if noise is getting added to analog signal, in the sense it may add at any place from 0 to +5 varaikku enga venalum it may get added, right? So I want to monitor each and every amplitude level and I want to check whether noise is added or not, right? Whereas in digital abdina, 0 to 1 abdina அந்த இடத்துல மட்டும் I can check. So after 1 க்கு மேல எனக்கு என்ன ஆட் ஆயிருந்தாலும் I don't want to consider, because it's an unwanted signal for me. I have transmitted only from 0 to 1, right? So this is what about your analog and digital communication is. Okay. Yes, students, can you understand what I have taught you so far? Can you get one clear picture of what is being discussed so far? Yes, right. So for another 5 to 10 minutes, let me tell you this analog communication and digital communication intro also. After that, we will see why we are moving from analog communication to digital communication. So go through this slide. So signal transmitted will be analog in nature. So analog signal in the sense it will be voice signal, video signal, or data signal, or any signal that is continuous in nature. I hope you know how the analog signal will be looking like. And entire transmission process is carried out by means of analog signal. This point is very, very, very important. So what I mean by this transmission process, can anyone guess? What do you mean by this transmission process? Can you guess what is this transmission process? By looking on to third point, you can easily tell. Depending on the frequency. Very good. So transmission process in the sense, so you have already said about modulation, demodulation, everything, right? So all those process should be carried out by for an analog signal, because our input is analog signal. So we are not disturbing that analog signal, and we are going to process everything by means of analog in nature, right? So what is the transmission process in the sense, if this process involved in this type of transmission is modulation at transmitter and demodulation at receiver end. Now comes into the picture of modulation. I'm explaining generally. So for transmitter end and receiver end only I'm explaining, right? Now you have to tell me what is this modulation. What is modulation and why we want to do modulation? Yes, students, what is modulation and what do you mean by modulation and why it is done? Changing the parameters of carrier signal with respect to message signal. Very good. So the main aim is we want to modify the signal. That is what your modulation concept is. For this, let me tell you one simple scenario. So when you and your friend are very near and you want to discuss something, how you will be discussing? Whether you will be using high tone or with medium voice or low voice. ரெண்டு பேரும் ரொம்ப பக்கம் பக்கமா இருக்கீங்க, how you will be discussing? Low voice, that is enough. அந்த இடத்துல நம்ம ஹையா பேசணும்னா what will happen? So I hope you get my question. So when two persons are very near to each other and they are discussing in very low noise, that will be better. And if they use high voice and if they speak something, what will happen? Others will also hear main thing, that one. So that may be that will be acting as a noise for another transmission. அடுத்தவங்க ரெண்டு பேர் பேசிட்டு இருக்கும்போது that may be disturbing them, right? And main thing என்ன ஆகுதுப்பா, நம்ம கத்தி கத்தி பேசினோம்னா what will happen? Our energy is wasted. Do you agree with this statement? Our total energy is getting wasted. Yes or no? Yes. So in order to minimize our resource, what we want to do is we want to talk in low voice for your for the friend who is near to you, right? Say for example, if you and your friend are 200 feet distance looking at, then how you will speak? You and your friend are standing with the difference of 200 feet, how you will be speaking then? Whether that low voice is enabled is sufficient? No. So you want to increase your tone, right? So for that purpose only we are going, that is also very similar to your communication. This is the basic principle for your modulation process and demodulation process. So when we want to transmit a signal over large frequency, large distance, what will happen? You want to go with the modulation process. Modulation process is nothing but adding one carrier to your original message signal. And I'll tell you one more scenario. If you people are sitting in an auditorium, say for example in our college auditorium, you people are sitting, around 1,000 students are sitting, what will happen if one person stands on a dais and if he or she speaks, mean whether the person who is sitting at the last will be hearing? Yes, whether that person will be hearing or not? So I hope you get my question. In an auditorium, there are 1,000 students sitting and one person is standing on dais and he is speaking. He is not using mic or anything. Whether that last person will be reaching that voice what the person is speaking? No, right? Because the distance is large and again disturbance is large, everything. Okay. So what we want to do, we want to go with one component called as a microphone, right? So that microphone, what will be, what is the actual process involved in microphone, students? Microphone is nothing but an amplifier, right? I hope you heard of this terminology in your analog electronics and all. So amplifier in the sense it will be increasing the signal strength. So that is what your modulation process also. So what is actually modulation? Addition of carrier signal to your message signal is called as modulation. And why we want to go with modulation in the sense it should be transmitted for a large, if the signal should be transmitted for a large distance, we want to go with your modulation concept. And the resultant signal, what is that resultant signal? It is combination of message signal plus carrier signal, that is called as a modulated signal. Are you all clear with this concept, students? Yes, are you all clear with this? Okay, now as I said, demodulation. So we are doing modulation at transmitter end. Demodulation should be done at your receiver end. What is that demodulation? Our ultimate aim is only message signal and we want to eliminate that carrier signal, right? So that carrier is nothing but it is supporting your message signal for transmitting your signal, and that carrier will not be having any information. So removing that carrier at your receiver end is called as a demodulation process or detection process. Are you clear with this concept, students? Yes or no? Are you clear with this concept? Yes. So, right. So with this, why and when we need modulation, I have explained you. So for reduction in height of an antenna, so antenna should not be that much height. So in order to avoid that, we want to go with modulation, and for covering large distance, we want to go with your modulation concept and multiplexing in the sense. So multiplexer, what is actually multiplexer concept is, in digital you have studied about multiplexer. What is that multiplexer? What is multiplexer? Students, what is multiplexer? Combine n channel into one. Correct. So many to one is called as multiplexer, right? So for that concept, modulation will be going with that multiplexer also. So one channel is enough for transmitting n number of signal. அதுக்கு ஒரு எக்ஸாம்பிள் சொல்லணும் அப்படின்னா, நம்ம வீட்ல கேபிள் டிவி இருக்கு இல்லையா? So in cable television, how many signals you will be receiving? How many channel you will be receiving? One channel or n number of channels? In television, through your cable, n number of channels you are receiving, right? So all those n number of channels are transmitted by how many cables? N cable or single cable? One cable. Very good, right? So that single cable length is capable of getting multiple channel, and that is called as a multiplexer. At receiver end, what we can do? We can split your signal according to the requirement. So based on your selection line, you can select a particular channel, and it improves the quality of reception. So your HD, we are seeing everything, so that quality of the picture also will be good when compared with without modulation signal. Are you clear with this, students? Right? Are you clear with this topics? Yes or no, students? Yes. So I don't want you rush till last minute. Next 5 minutes I left to you. The forum is open for you. You can discuss something. So let me go like this. In all session, not only in this session, last 5 to 10 minutes I'll be allocating for you. But the thing is, you want to do something effectively. So it can, usually I'll be for present final year students and all, I'll be giving 15 minutes time. They'll be having some discussion or sharing their knowledge like that. So if நானே பேசிட்டு இருந்தேன் அப்படின்னா, it will not be fine. It will be like a monotonous teaching, and that should not happen in this online and virtual mode. So for that purpose, let me give you 5 more minutes so that you can plan and you can discuss something that is useful for all of us. Okay? Yes or no, students? Yes or no? Why you people are so silent? You feel hesitated to unmute and speak? Students, I'm asking you only whether you're convenient with that or not. I think you want content problems, sir. Okay. இன்னைக்கு வேண்டாம். I'm not telling that. In today's class, so let me stop the recording process.